Okay, class, today we are going to be doing section 4.6, which is graphing tangent and cotangent. So here I have some input values for our angle, and I'm going to plug my x value into for tangent for the x value. So for the first one, I want to find tangent of 0 on the unit circle. So I'm going to be looking at the unit circle for the angle 0, which is over here where the coordinates are 1, 0, and tangent is the y coordinate over the x coordinate, so it's 0 over 1 or 0. And then I'm going to find tangent of pi over 4, and the coordinates at pi over 4 were root 2 over 2, root 2 over 2. So when I find tangent of pi over 4, I'm going to do root 2 over 2 over root 2 over 2, which is 1. Then at pi over 2, which is straight up, tangent is y over x, so it would be 1 over 0 or undefined. So go ahead and continue in this pattern, finding all these. So pause the video now, continue. Okay, so you should have gotten this for the remainder of the values. So what I'm going to do after I've completed the table using the unit circle, I'm going to use these as some of my key points to help me plot. So I have the graph of tangent. This is actually 3 periods of tangent. So I'm going to plot these points. I'm going to plot 0, 0, which right here, so it goes to the origin, and I'm going to plot pi over 4. Well, I have that this value here is 3 pi over 2 because it says 1.5. So if I just split this up, I can see what they are. So if this is 3 pi over 2, I can divvy it up, and so I know that this is 1 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. So these are each my pi over 4 values, which goes with my table. So if I look at pi over 4, I have 1, and you can see it goes through there. Pi over 2, it's undefined, and we draw the undefined with a vertical asymptote. At 3 pi over 4, it's at -1. And then at pi, it's at 0. 5 pi over 4, we're at 1. 3 pi over 2, it's undefined, and so on. It keeps going like this. And if I had my table go the other direction, I could, of course, do this. So what I have here is 1 period of tangent. So 1 period of tangent goes from an asymptote, these 3 dots, and then another asymptote. So we're going to have our 5 key points as shown. Asymptote, 3 dots, asymptotes. And this is the shape of 1 tangent. And you know that it keeps repeating over and over again. So we see that 1 period goes from this value here where this asymptote is, which is minus pi over 2, all the way to this asymptote, which is at positive pi over 2. So 1 period of tangent is pi. So in general, tangent has period pi over b. In this particular instance, the period is pi, but now the rule is going to be pi over b. Sine, cosine, secant, and cosecant, the period was 2 pi over b. This changes. So for this particular example, because it is just tangent and period is pi, and our x-axis scaling is going to be pi over 4. So we're still going to divide it into 4 so that we know that it's split into 4 pieces, just like before. Our vertical asymptotes, just like secant and cosecant, it's x equals, you look for the first non-negative asymptote, which is at pi over 2. Plus n times the period, and the period in this case is pi. It's the distance between your asymptotes, just like it was for secant and cosecant. So if the first non-negative asymptote is at pi over 2 and the next asymptote is 3 pi over 2, it's 1 period away, or in other words, it's pi away in this example. So that's the equation of that. The domain is also all real numbers except your vertical asymptotes. So except x equals pi over 2 plus n pi. And then the range is the y values. Well, my graph, my blue, goes down to -infinity, and there are arrows on it, and then it goes up, and it has an arrow on it. So there is no break. So the domain is actually all real numbers. Or you can say -infinity to infinity. Okay, so let's go ahead and take this information and do our first graph. So the first one, we want to graph 2 periods of y equals 4 tangent 2x minus 1. So here we see we have a period change. Oops, excuse me. We have a change in the period. We have a change in the vertical shift. We have a change in the amplitude. So we can go and find some of our things. So the period is always going to be pi over b, and my b is 2. So my period is pi over 2. My x-axis is period over 4, so it's pi over 2 over 4, which is pi over 8. So I'm going to make my x-axis in pi over 8. So next, what I want to do in order to find the vertical asymptote, so I'm going to write the equation and find the domain and the range after I do my graph. So I know my amplitude is 4. So what we're going to do is we're going to change the values of these things. So originally, here we had the amplitude was 1 for the graph of tangent, and these values were at 1. Well, where these 2 points lie depends on what the amplitude is. And the center point here is normally on the midline or the center line. So that will change with the vertical shift line. So for this example, we are going to shift down 1. So I know at -1 is where my midline is going to be. That's the middle, because tangent's middle point is on the midline, and then it's going to go up and down from there. And then it's going to have our other 2 dots here and here at our amplitude away. So this is going to help us with our amplitude. And then the other dots are actually our asymptotes for our key points. Okay, so I know that my amplitude is 4 and I have a vertical shift of 1. So I'm going to go down 1. And so now I'm at -1. I'm going to go up 4. 1, 2, 3, 4. And over 1 box. And then my amplitude, I can go down 1, 2, 3, 4, and left 1. And then my next one over is going to be the vertical asymptote. And 1 over the other direction is a vertical asymptote. And these are going to be the 5 things that make up the tangent graph. So the middle, the amplitude, and the min. So I have -1, 3, and -5. And then I'm going to connect. So my top half connects with a upward curve, and this is going to be a downward curve. Okay, so it does need to have this curvy shape, which is really hard to do when it's so elongated. Now I said my x-axis scale was pi over 8. So my first one was pi over 8. My second one was pi over 4, or 2 pi over 8. And I have minus pi over 8 and 2 pi over 8, which is minus pi over 4. So that is what one period of tangent looks like. And we can see it's going from minus pi over 4 to positive pi over 4, which is 2 pi over 4, or pi over 2. So I graphed the period. Now I have to graph 2 periods. I'm going to graph one more. So I know that there's 4 boxes to my next asymptote. 1, 2, 3, 4. So I'm going to draw my next asymptote. And I know the midway point is my middle line, which is on my midline of down -1 is my middle point. And then I'm going to go 1 to the right and go the amplitude up. And then from my middle point, I'm going to go 1 to the left and my amplitude down. And we're always going to have this sort of symmetry on my graph. And remember, our graphs are approaching the asymptote, doesn't touch or cross the asymptote. And I'm going to fill in the remainder of my key points. And I'm counting in pi over 8s because that was my scale. So 1 pi over 8, 2 pi over 8, 3 pi over 8. 4 pi over 8, 5 pi over 8, and 6 pi over 8, which is 3 pi over 4. Okay, so now I filled out my scaling everywhere on my x and my y axis. Now I'm ready to write the equation for my vertical asymptotes. It's always x equals, find the first non-negative asymptote, which is at pi over 4, plus n times the distance between my asymptotes from 1 pi over 4 to 3 pi over 4, 3 minus 1 is 2, so it's pi over 2. And it's always going to be whatever the period is for tangent and cotangent. Okay, so now I'm on to the domain. So for the domain, I'm going to look at that it's all real numbers except for where it's undefined, which is at the asymptote. So it's all real numbers except at x equals pi over 4 plus n pi over 2. And the range goes from minus infinity to infinity, which is all real numbers. Okay, so let's go on to the next one. So here we're going to do a negative tangent function. So negatives, are going to be a reflection on the x-axis. So we have a reflection on the x-axis, and negatives out front are always reflections on the x-axis. So instead of being at the midline and going up and down, it's going to reflect. So we're going to take the middle, and it's going to, this piece is going to reflect down, and instead of this piece here, it's going to reflect up. So this graph here is our negative tangent shape. And it's the same idea for everything else. So we're going to have a vertical shift up 3. We don't have a change in the period, so the period is pi, because our b is 1, and our amplitude is the absolute value, so our amplitude is 2. So we're going to start in the middle, and we're going to go up 3. 1, 2, 3. So this is our middle value. And since we have the y equals negative tangent shape, we go over one key point and up our amplitude. So we're going to go, our amplitude is 2, over 1, up 2. We're over 1, down 2, because our amplitude is 2. We're going to go over one more box, and that's where our first asymptote is. And I'm going to draw in my curve. And then I want 2 periods, so I'm going to count over 1, 2, 3, 4 boxes for my next asymptote. I'm going to find the midpoint halfway between my asymptotes and go up 3 for my midline. And I'm going to go to the left and up your amplitude, and go to the right and down my amplitude. And I'm going to draw my curves so that they approach the asymptotes. So my period was pi over b, or in this case pi. X scale is always period over 4. So I need to make sure I mark mine in pi over 4, every pi over 4, 3 pi over 4 pi, 5 pi over 4, 3 pi over 2. I'm going to do that on the negative x-axis as well. Okay, so I jumped ahead, and I did my negative x-axis, and I did my y, 1, 3, and 5 for my vertical shift and my amplitude. So my vertical asymptote is going to be x equals, I look for my first non-negative asymptote, which is at pi over 2, plus the period, or the distance between the asymptote, which is pi, from 3 pi over 2 minus pi over 2 is pi. So I wrote it pi n, you can write it n pi, both are correct. The domain is the x values, and it's, again, all real numbers except x equals pi over 2 plus n pi, or pi n, because it's not defined at the asymptote, so that's where it's undefined. And the range is the y values. It's going down to negative infinity, and it's going up to infinity, and it has all y values in between. So the range is going to be all real numbers. For tangent, negative tangent, and then also cotangent, you'll see that the range is always all real numbers. So that is how we are going to graph tangent. So the next video will be graphing cotangent.